Hey chemistry students, we're going to do lesson 2.4b, which is an extension of density. We're going to learn more about density, and we want you to learn to solve more involved, more complicated density problems, and also to recognize extensive and intensive properties. So let's actually start with that second objective. Some properties are extensive. An extensive property is one that depends on the amount of matter that you have. So obviously that includes, a lot of measured properties, things like mass, volume, but not all properties are extensive. The temperature of something really doesn't depend on how much you have. It depends on how hot it is, but not how much. So that would be what we would describe as an intensive property. So intensive properties don't, that's a D, don't depend on the amount of substance that you have. So temperature is one, and another important intensive property is density. Chemical properties are intensive. Things like reactivity don't really depend on the quantity or the amount, just on the substance itself. So both properties are useful. Obviously, we like being able to measure the quantity of matter, and the extensive properties are very important for that. But intensive properties are also useful. Things like density, are characteristics of a substance. So they can be used to identify things. Melting point is an intensive property. The temperature at which something melts from a solid to a liquid is often a characteristic of that substance, and these kinds of properties can be useful in identifying things. So as we go through these density problems, you're going to see the usefulness of these intensive properties. Once you find the density, then you can identify something from that, or at least it will help you to identify it. So on to some problems. Okay, so what we're going to move into now is some, let's call them next level density problems, where it's not just mass, volume, divide, get density, where you have to do a little more work, but you have to remember you're always going to be given enough information in these to solve the problem. You just have to read it and figure out what it's asking you to do.
And also, if we give you a more difficult question, we'll usually give you outside equations if they need apply.
If there's some outside equations, you'll get them. So this one is going to involve finding density or finding the volume by displacement. Like, you're not going to be told the volume, you have to find it by displacement. So Mr. Hunter, let's review what displacement is.
Alright, well, displacement, let's say we have this graduated cylinder over here, and we have a line of water right here on the 20.0 milliliter mark. And Mr. Ferguson, coming home from his hand modeling, decides to drop off his gloves into the graduated cylinder, and it raises it to 40 milliliters, 40.0 milliliters. So I displaced water from that point up, and how many milliliters have I displaced so far, Mr. Ferguson?
Well, we would have to take the spot where it ended up, which was 40.
So volume final.
And we're going to subtract off the amount of volume that was already in the cylinder, which would be the initial volume. So it's going to be the 40 minus 20, which would be 20 milliliters, 20.0 milliliters.
So 40 minus 20 equals 20 milliliters.
So it's going to be the final volume minus the initial volume gives you the displacement.
So volume displaced, there we go. Alright, we're going to drag out a example here in a second. Just let me clear this off. There we go. Hopefully this is working. Alright, let's drag out our next problem, which is not showing up for some reason. Alright, so looking at this example, we have a metal object that is placed into a graduated cylinder containing 6.32 milliliters of water. The volume then increases to 7.68 milliliters. The mass of the object was found to be 0.00980 kilograms. We want to find out the likely identity of the metal. So, Mr. Ferguson, where do we begin?
Well, obviously we're going to have to use the density that we calculate to identify the metal. So we're going to begin by figuring out the density, and we were told a mass, but we didn't get told the volume directly. So let's start by finding the volume by this displacement method.
Right, so final volume minus initial volume.
And I'm getting on the calculator 1.36 milliliters.
Is this correct, sig figs?
Yes, both had to the hundredths place, so we're good.
Alright.
Okay, now, the next thing I'm noticing is that we did get a mass, but unfortunately it's not in the unit we'd really like it to be for density. It's in kilograms, so we're going to have to convert our mass in kilograms into grams.
Alright, setting up our fence post. We know there's 10 to the negative 3 kilograms for every 1 gram.
So
this is going to equal...
that's going to equal 9.80 grams.
0 grams. And lastly, correct number of sig figs, yes or no?
That is correct, because we have only 3 significant digits in the kilogram measurement. Only the last 0 significant. The beginning ones are placeholders. So we're good. So now we have a mass and a volume that we can work with. So we've got the 1.36 milliliters and the 9.80 grams.
Yep.
So our density is going to be the mass divided by the volume. 9.80 grams divided by 1.36 milliliters. And the calculator tells me that the answer is 0.20588.
So 7.20588 grams per milliliter. You have to stop. Of course, these are 2 measurements. This one has 3. This one has 3. So our answer should only have 3. So we should round this to 7.21 grams per milliliter. Now, the last part of this question asks us the identity of the metal. So we have this chart right here. Alright, kind of getting in the way. There we go. Let's take a look. There we have it. We have iron as 7.21. We found our answer to be 7.21. So we would say that iron cast would be our most likely metal. Alright, let's try another difficult question on the next slide.
Okay, so another variation you can see in these is where they ask you to pull a little geometry out of your pocket to calculate the volume based on length measurements. And there's all different volume formulas, but we're going to focus on rectangular type solids, like Mr. Hunter's drawing, something that's roughly a cube or block shape.
Tempting to. This is actually more difficult on this than you think.
Okay, so the basic formula for something that has a brick, a box, cube shape.
Let me label that for you.
That's kind of a impressionist cube there. Little Picasso.
I never said I was good at
So
art.
that's length times width times height.
Alright, let's try the next shape.
So the next shape that we're going to often encounter, it would be a cylinder shape.
Yeah, it's better.
Okay, and the cylinder, the volume is going to be the area of the end, pi r squared, multiplied by the height or length, pi r squared h. So that would be h, and of course the radius is half of the diameter.
Yeah, I can't draw that with this pen, but it's in the circle there. You have the center point draw it out, R.
So it's basic geometry. You're going to get a unit. If the measurements are in centimeters, you're going to get cubic centimeters. If they're not in centimeters, then we have to be careful. All right, so let's
get those recorded. So I'm going to delete them off the screen here, and now we're going to pull out our next equation, and let's solve it.
So we've got a cube of copper. And it's got, so it's a cube, all the sides are the same length, all the edges are the same length.
Let's try this again.
It's 0.410 meters on a side. And we're asked to predict its mass, and we're given the density value for copper.
Alright.
So, the first thing we're going to need to do is...
Volume equals length times width times height for a cube. So that's the first equation we're going to need. Right.
But if we look at the given length,
good call.
It's in meters.
It is
so
in
now,
meters.
if we take that value times itself again, we're going to have an answer in cubic meters, which we really don't want. So the first thing we need to do is convert it into
Let me try this again.
Centimeters.
0.410 meters. Convert to centimeters, you say. Meters, centimeter.
So I believe it's
1 meter
is
every
100 centimeters.
100 centimeters. So that should equal out 41.
41.0, because that zero is significant.
Yes, and we have to have the same number of sig figs.
41.0 centimeters.
There we have it.
All right, so now we've got a density, and we've got a...
Oh, I'm going to move this out of the way.
I'm sorry. We have a length now of a side, but we still don't have a volume yet.
Now we need to solve our volume problem now.
So now we're going to take it up since it's length times width times height, and they're all identical on a cube. It's just 41.0 times 41.0 times 41.0, or if you
are lazy,
41.0 cubed. Either way you slice it, you're going to get
a big number. What is that? 2803221. All right, the calculator says it's 68921 centimeters cubed. But our answer should only have three significant figures, so it should equal 68900 centimeters cubed. No
That's
decimal.
a big cube of copper.
That's a big cube of copper. Okay. All right, let's go on to the next step then. All right, so the next step is to now figure out our density. So we know our normal density equals dm divided by v, but we want to solve for mass, so multiply both sides by v. So mass equals volume times density. We now plug these in, so equals the volume 68900 centimeters cubed, and we're going to multiply that by the density given up here of 8.933. We're going to have room for my units. There we go. And Mr. Ferguson, what does the calculator give us?
Calculator says
615,483.7 grams. And our final answer should have how many sig figs?
Well, we had 3 in our original measurement of the length. And we multiplied, and then we divided, so we should still keep 3.
We are multiplying by 4 significant figures, though, for that density. What do we remember about that density?
But that's a given value.
All right, what do we do about givens?
We pretend they have infinite significant figures, so they're always going to have more sig figs than whatever measured values are in there.
So we ignore them. So our final answer should only have 3 sig figs, so it should be 6.15 times 10 to the 5th grams of... This is copper. And this is a more difficult density problem.
Right, because we had to get a little unit conversion involved. We had to calculate the volume instead of just taking it from the given in the problem. But it's just breaking it down, and it becomes one big problem becomes a series of small doable problems.
Exactly. That's the first step. You have to think about your pathway for any problem. We're going to start you now on one more really difficult one, and we're going to have it as an extra credit for tomorrow's quiz if you can work it out.
So if you don't like math, you should probably stop the
Stop
video
listening now and just have a good night. All right, next problem. Real
So this is just an over-the-top density problem.
But not unreasonable.
Not
to see.
unreasonable, and again, it breaks down to a series of small doable problems.
What we're working on in this class.
So we've got a piece of aluminum bar stock, which would be a solid piece of aluminum. It's kind of shaped like a very long stick of butter sort of shape. It's 2.30 centimeters in cross section.
For those who don't know what that means, he's drawing it on here. It says each side of this is 2.30
So it's 2.3 centimeters here, and it's 2.30 centimeters there. It's a square on the end.
I didn't even know that, so we were already in the same boat for this one.
And we've cut a length of this piece, which is 3.61 meters in length.
Yeah, let's make this bigger for right now, because we're going to draw some holes in this puppy.
So here is, the size of the thing. Now, 6 holes measuring 8.00 millimeters in diameter are bored into the bar across its narrow dimension. So that would mean we would have, I'm just going to draw one of the holes. So it would be a hole here that is across its diameter, 8 millimeters.
And there's
and it
6
would go
of these.
all the way through to the opposite side. So it's a cylinder.
And you have 6 of these cylinders bored
and
through.
And there's 6 of them, so it's this times 6, all down the length of that. So the density of aluminum is given, and you're supposed to use math to find the final mass of the bar.
Yeah, so right now we're not going to actually do this one for you. Like you said, this is going to be an extra credit problem. We're going to find the pathway for you and give you all the extraneous equations that you would be given on a test if we were doing something like this to you.
So my first strategy is, what would you do first, Mr. Hunter, if you're given this?
Gnash my teeth because I didn't know what a cross-section was.
Okay, so after you got done complaining about the evil person who wrote this.
Well, the first thing I would do is I would figure out the volume of those holes, to be honest. That's just the way I am.
Now, see, I would come at it from a different way, but let's go with that. So find volume of, and I would start with just one hole.
Oh yeah.
They're all 6 sides. So
you find the volume of one hole multiplied by 6. And times by 6.
And then take it times 6.
Exactly.
Now note that the volume's in millimeters, so if you want it to be cubic centimeters,
it has to go.
So you're going to have to do the conversion.
Millimeters to centimeters. So let's write this down for him. Well, let's not write that down for him. Let's still give him the equation for a volume of a hole instead.
You would want to remember that volume of a cylinder is pi r squared times h.
Yep. So there's your first equation.
Okay.
So the second thing, after I found that, I would go for the total volume of the bar.
Bar volume. So the V, that's just a big
blank times width times height.
L times W times H.
And we are fortunate that it is already in centimeters. Thank you for not being too evil.
No, only 2 of the 3 are.
Oh, right. Right, the length.
You got the little length here in meters, so
that's a really long piece of
that's a
aluminum
long
bar.
piece of aluminum bar.
So you have to convert those meters to centimeters, or convert everything to meters. It doesn't really matter, I guess, in the end. But our density is given in grams.
I'd go with cubic centimeters for everything.
Yeah, I'll go with centimeters as well.
Okay.
So borrow the volume, and then step 3, after converting, of course, would be to subtract those 6 holes. Nice color change, by the way.
Volume bar minus
the
volume
of holes
equals volume
final. There you go. And then we're just one step away. What's the last step? Actually, we're done there, aren't we?
No, well, we would now know the volume.
And now we would have to use the density. There you go. We have one more step. We would have to use the density equation to solve for the mass. And then we'd be done. So it's not that difficult. All in all, each step is very doable. We have problems like this we're going to give to you throughout the year, especially at the end of the year when we give you that nice question Mr. Ferguson and I thought up together. We have like 4 or 5 of them we're going to give to you at the end of the year. which is multi-step, similar to this, but it incorporates everything throughout the year. So, well, good luck on this one.
Good luck.
And we'll,
should you choose to accept this mission.
If you come in tomorrow with a little less hair in your head, we understand why. Have a good night.